Hi, in this video, we're going to be looking at guided notes for Lesson B. Specifically, we're going to start in this video with proportions, and in our next video, we'll look at how to scale a graph. So proportions, as you see here, the definition of a proportion is a part, share, or number considered in comparison to a whole. And we write that as a fraction. So example 1 says, if Jack answered 17 questions correctly out of 20, his proportion correct is... it asked for his proportion correct, and the correct number was 17, and the total was 20. So we simply write 17 over 20, and that is the proportion correct. Now, if we wanted to reduce this fraction or change it to a decimal, let's look at how we would do that on Desmos. If you have Desmos up, you would just do 17 divided by 20, and that gives us 0.85. Now, I'm not sure if this fraction reduces, but Desmos has this nice little fraction symbol here in the corner. If we click on it, it will reduce the fraction for us. Now, this fraction gave us the same answer, so we know that 17 over 20 is already reduced. So we can leave this as 17 over 20. Of course, we found that it also said it equaled 0.85 if we wanted to write it as a decimal. Or as a percent, we know to move the decimal over 2 places, and we could write it as 85%. All three of those would be correct. Let's look at another example. In example 2, it says 95 students in Math 042C were asked how many hours they spent per week on their math assignments. The responses were organized in the table below. What is the proportion of students who spent 3 to 4 hours per week? So if we look, our top row says how many hours, and our bottom row shows how many students spent that many hours. So we can see here that 2 to 3 hours, 9 students spent 2 to 3 hours, 12 students spent 5 to 6 hours, etc. To find the proportion, we know that we put the total number on bottom and the number that we're speaking about on top. It told us the total number. If it had not, we could go to our table and add up the total this way, but it should give us 95, which is the same. Now it wanted the proportion of students who spent 3 to 4 hours. So we go to that place in our table and we see that was 12 over 95. To see if that fraction reduces, we can go once again to Desmos and type in 12 divided by 95. Oh, and it gave us 12 over 95. So it looks like 12 over 95 doesn't reduce. If we wanted it as a decimal, we'd put 0.126 or 0.1263. So we can leave it as 12 over 95 if we want a reduced fraction. All right, let's look at some definitions here. From Math 142, you know that the population proportion is represented by the lowercase p, and that's equal to the fraction of R, which is the number of successes observed in the population, over capital N, which the total number of times the activity could be tried, and this should say in the population. When we use a capital letter, that's always referring to the population. R is the same for both. If they want to talk about sample proportion, we use the symbol P with a little arrow over it, the lowercase p with an arrow over it. We call that P hat. And once again, that's R, the number of successes observed, over lowercase n this time, which is the total number of times the activity was tried, and this would be in the sample. Let's continue. Example 3 is another example of proportion, and it says, in May 2026, Flagstaff held a special election to ratify the Flagstaff Regional Land Use Plan 2045. Of the 5,911 votes that came in, 3,369 voted in favor of the plan, while 2,542 voted against the measure. What is the proportion of people who voted for the land use plan? So we know that proportion is P. We put the total number on bottom and the successes on top. In this case, Successes would be considered the people who voted for the land use plan, which is that 3369. So that goes on top of our fraction, and the total number, 5,911, goes on bottom. I don't know if that reduces, so let's go to Desmos and see what we get. If we do, I don't remember what the number was, 3369? Yep. 3369 divided by 5,911. Sorry about that. We get 0.5699 and it repeats. I don't think this one reduces, but to check, we can hit convert to a fraction and it gave us that same response. So we know that this is a reduced fraction and we can leave our answer that way. All right, so that's proportions in a nutshell. In our next video, we're going to look at how to scale a graph. Thanks for watching.